There's a phrase that used to mean something. Made in Germany. For decades, it was stamped on the best cars, the most precise machinery, the engineering that defined quality itself. A Mercedes didn't just run, it ran perfectly for decades. A Siemens turbine didn't just work, it worked flawlessly, engineered to tolerances measured in microns. German engineering wasn't marketing. It was physics made reliable. But something broke. In 2024, Volkswagen, the largest automaker in Europe, announced it would close at least 3 factories in Germany for the first time in its 87-year history. BASF, the world's largest chemical company, is moving production out of Germany permanently. Siemens Energy is hemorrhaging cash. Germany's industrial production has fallen 12% since 2017, erasing nearly a decade of growth. This isn't a recession. This is structural collapse. The country that rebuilt itself from total wartime devastation into Europe's industrial superpower in less than 15 years now can't compete with Chinese startups. The engineers who could machine a crankshaft to perfection can't write the software that runs a modern car. The factories that produce the world's best diesel engines are being undercut by Chinese EVs that cost half as much and ship twice as fast. Here's the contradiction. Germany still has world-class engineers. It still has advanced manufacturing. It still has a reputation for quality. But none of that matters anymore. Because while German engineers spent 30 years perfecting panel gaps, the world moved to batteries, software, and speed. And now, made in Germany isn't a competitive advantage. It's a liability. If this kind of analysis is valuable to you, hit the like button and subscribe to the channel. It helps this content reach more people who want to understand what's really happening beneath the surface. Now, let's continue. The German engineering model is dying because it optimized for the wrong century. It perfected mechanical precision in an era that demands software velocity. It built an industrial base on cheap Russian gas that no longer exists. It trained generations of engineers who are now retiring with no one to replace them. It designed premium products for a market that wants affordable EVs. And it created a regulatory system so complex that building a factory takes 3 times longer than in China. These aren't separate problems. They're 5 structural failures that compound into systemic obsolescence. Each one alone would be manageable. Together, they're terminal. We're going to examine each failure in detail, how it emerged, what the data shows, and why it can't be easily fixed. Then we'll look at how they interact to create a doom loop that's accelerating. By the end, you'll understand why Germany's industrial decline isn't temporary adjustment. It's permanent transformation. And why the German engineer, once the gold standard of technical competence, is becoming a relic of the 20th century. Let's start with the most symbolic failure, the obsession that built the reputation but now destroys it. There's a German word that captures everything beautiful and terrible about German engineering, Spaltmaß. It means panel gap, the space between body panels on a car. In German automotive culture, Spaltmaß became an obsession. Mercedes engineers would spend months perfecting the gap between a door and fender, ensuring it was uniform to within half a millimeter across the entire vehicle. This wasn't just quality control. This was philosophy. The visible precision of panel gaps symbolized the invisible precision of everything underneath. And it worked. For decades, that obsession with mechanical perfection made German cars the best in the world. A 1995 Mercedes E-Class felt more solid than a 2020 Tesla Model 3. The doors closed with a bank vault thunk. The switchgear had damped, progressive resistance. Everything was engineered not just to function, but to feel engineered. But here's what happened. While German engineers were perfecting millimeter-level mechanical tolerances, the automotive industry fundamentally changed. Cars became computers with wheels. The value shifted from mechanical precision to software capability. A modern electric vehicle has maybe 20 moving parts in the powertrain compared to 2,000 in a combustion engine. The engineering challenge isn't machining a crankshaft to perfect tolerances anymore. It's writing the software that manages battery thermal systems, or optimizing the neural networks that run driver assistance, or designing the supply chain that delivers batteries at $100 per kilowatt-hour instead of $140. Tesla's panel gaps are famously terrible. Early Model 3s had gaps you could stick your finger through. But Tesla dominated the EV market anyway, because buyers didn't care about panel gaps. They cared about over-the-air software updates, about supercharger networks, about 0 to 60 times that embarrassed sports cars. Tesla's engineering priorities were completely inverted from Germany's. Ship fast, iterate constantly, fix it in software. German automakers saw this and thought Tesla was cutting corners. They thought quality would win eventually. Volkswagen spent $50 billion developing the MEB electric platform with the explicit goal of matching Tesla's volume while maintaining Volkswagen quality standards. The result was the ID.3, launched in 2020 as the electric successor to the Golf. The ID.3 debacle reveals everything. The car launched with such catastrophic software problems that Volkswagen had to manually update each vehicle's software in parking lots before delivery. The infotainment system crashed constantly. The voice recognition didn't work. Basic features like App Connect weren't available at launch. Meanwhile, the panel gaps were perfect. Volkswagen had allocated thousands of engineering hours to mechanical precision and assumed the software would just work. It didn't. Because software engineering and mechanical engineering are fundamentally different disciplines, and German automakers had spent 30 years hiring mechanical engineers while Tesla hired software engineers. The numbers show the result. In 2023, Volkswagen delivered 140,800 ID.3s globally. That's respectable, except it's down from initial projections of 330,000 annually. The car's insufficient demand forced Volkswagen to cancel third-shift production at Zwickau and abandon plans to build ID.3s at the Wolfsburg plant entirely. By 2024, Volkswagen was cutting ID.3 prices by €3,000 just to move inventory. Compare that to Tesla. The Model 3, with its terrible panel gaps and occasionally misaligned bumpers, delivered 1.79 million vehicles globally in 2024. Or look at BYD, the Chinese EV maker that didn't even exist in the passenger car market 15 years ago. BYD delivered 1.76 million battery electric vehicles in 2024, nearly matching Tesla, with panel gaps that would make a German engineer weep. This is the Spaltmaß Trap. German engineering culture optimized relentlessly for mechanical perfection, the visible, tactile quality that customers could see and feel. That optimization worked brilliantly when mechanical systems were the primary differentiator. But as vehicles became software platforms, that same obsessive focus became a liability. The engineering hours spent perfecting a door seal could have been spent developing better battery management systems. The cultural emphasis on mechanical tolerances prevented the cultural shift needed to prioritize software velocity. And now German automakers are caught. They can't abandon their mechanical precision. That's their brand identity, their cultural heritage, the thing their engineers were trained to do. But they also can't compete purely on software with companies that built their entire culture around rapid iteration and software-first design. The result? German electric vehicles that are mechanically excellent and digitally mediocre, competing in a market that doesn't value mechanical excellence anymore. The Spaltmaß that once symbolized German superiority now symbolizes German obsolescence. Perfect panel gaps on cars that can't compete. But the mechanical precision problem is just symptom. The deeper crisis is energetic. Because the entire German industrial model was built on an assumption that no longer exists. On September 26, 2022, something exploded under the Baltic Sea. The Nord Stream 1 and Nord Stream 2 pipelines, the arteries that carried Russian natural gas directly to Germany, ruptured in what was almost certainly sabotage. The explosions were largely symbolic. Russia had already shut off gas flows in August. But the permanent destruction of the pipelines marked the definitive end of Germany's 50-year energy strategy. That strategy was brutally simple: buy the cheapest energy possible to power the most energy-intensive industries in Europe. Natural gas from Russia cost roughly half what liquefied natural gas from the United States cost, after factoring in transportation. That price advantage wasn't marginal. It was structural. It made German chemical plants, steel works, and manufacturing competitive globally. The numbers were staggering. In 2020, before the energy crisis, German industrial electricity prices averaged 5.92 cents per kilowatt-hour for large customers. By August 2022, at the peak of the crisis, prices hit 40 cents per kilowatt-hour, a 576% increase. Even after normalization in 2024, industrial electricity prices remain around 16 to 17 cents per kilowatt-hour. That's still 177% higher than pre-crisis levels. To understand what that means in practice, German chemical giant BASF estimated that the energy crisis increased its annual costs by approximately 2.2 billion euros. Not temporarily, structurally. Because even as gas prices fell from their 2022 peaks, they never returned to pre-war levels and never will. Russia was Germany's cheap gas supplier. That relationship is permanently severed. The result, BASF announced in early 2024 that it would permanently downsize its Ludwigshafen site, the largest integrated chemical complex in the world, employing 39,000 people. Not close it entirely, but permanently reduce production capacity in energy-intensive product lines. The company is shifting 10 billion euros in investment to China instead, where energy costs remain low. That's one company. Across German industry, the pattern repeats. ThyssenKrupp, Germany's largest steel producer, is moving production capacity abroad. Aluminum smelters have shut down. The metal requires massive electricity input, and at European prices, it's simply not economical. Fertilizer plants that depend on natural gas as both energy source and feedstock have closed. This isn't cyclical. This is permanent capacity destruction. The industrial base that made Germany the workshop of Europe depended on energy prices that no longer exist and won't return. But here's where it gets worse. This crisis was self-inflicted. Germany had options. It chose badly. In 2011, after the Fukushima disaster in Japan, Germany announced Energiewende, the energy transition. The plan, phase out nuclear power by 2022 and replace it with renewables, primarily wind and solar, supplemented by natural gas as a bridge fuel. Nuclear provided 25% of Germany's electricity. The plan assumed that gap could be filled by building solar and wind capacity rapidly, while using cheap Russian gas to handle intermittency. By April 2023, Germany shut down its last 3 nuclear reactors, Isar 2, Emsland, and Neckarwestheim 2, each still fully operational, each capable of producing reliable baseload power with zero carbon emissions. The shutdown removed 4.3 gigawatts of carbon-free generating capacity at the exact moment when energy prices were catastrophically high. The alternative, solar and wind, is intermittent. On cloudy, windless winter days, Germany now imports electricity from France's nuclear plants and burns more coal. In 2024, despite massive renewable build-out, coal still generated 24% of Germany's electricity, down from 46% in 2008 but up from pandemic-era lows. So Germany simultaneously, 1. Lost access to cheap Russian gas, 2. Shut down its nuclear fleet, 3. Failed to build enough renewables to compensate, and 4. Became more dependent on coal and electricity imports. This combination drove industrial electricity prices to levels that make energy-intensive manufacturing uncompetitive. The real comparison is brutal. In 2024, industrial electricity prices in Germany averaged 16.65 cents per kilowatt-hour. In the United States, they averaged 7 to 8 cents. In China, they averaged 6 to 7 cents. That's a 100 to 150% cost disadvantage on one of the largest industrial input costs. For a chemical plant or aluminum smelter, that price difference determines profitability. For an automaker, it's less direct but still significant. Higher electricity costs raise the price of steel, aluminum, plastics, and every other industrial input. The entire supply chain becomes more expensive. The energy crisis exposed the fundamental vulnerability of Germany's industrial model. It was built on cheap energy from an autocratic supplier with no backup plan. When that supplier became hostile, and when Germany's own energy policy choices prevented alternatives, the model broke. German industry now operates with a permanent competitive disadvantage. Every kilowatt-hour costs more than in competitor nations. Every ton of steel, every unit of chemical production, every manufactured component carries that extra energy cost. Some industries can absorb it. Energy-intensive industries cannot. And while the energy crisis emerged suddenly, the demographic crisis has been visible for 30 years. Germany just ignored it. Now the bill is due. Here's a number that should terrify German industry: 1.7 million. That's the number of unfilled job openings in Germany in 2024. Not because there aren't jobs, because there aren't workers. The German workforce is aging off a cliff. The country's working-age population, defined as people aged 15 to 64, stands at approximately 51 million in 2024. But projections from Germany's Federal Statistics Office show that number falling to between 37 and 45 million by 2070, depending on immigration levels. That's a potential 27% decline in the workforce. But the headline numbers understate the crisis, because the problem isn't just total population, it's age distribution. Germany's engineering workforce is dominated by baby boomers who are now retiring en masse. In 2024, the employment rate for workers aged 60 to 64 stood at 66.7%, up from just 19.6% in 2000. That massive increase in older worker participation temporarily masked the demographic problem. But those workers are now turning 65 and leaving the workforce entirely, and there aren't enough younger engineers to replace them. The numbers on engineering talent are stark. In 2024, approximately 40% of apprenticeship positions in Germany went unfilled. These aren't low-skill positions. These are the technical training programs that have traditionally fed German industry with skilled workers. The dual education system, where young Germans split time between classroom learning and on-the-job training, produced generations of world-class technicians. But young Germans increasingly choose university over apprenticeships, and those who do pursue technical training often leave manufacturing for other sectors. The result: German automakers and industrial companies are facing a gray tsunami, a wave of retirements with insufficient replacements. At Volkswagen, the average age of the workforce is rising steadily. At Siemens, experienced engineers are retiring, taking decades of institutional knowledge with them. Attempts to attract younger workers run into a fundamental problem. Young talent, especially software engineers, don't want to work in traditional manufacturing. Tesla's Gigafactory Berlin provides a stark illustration. When the factory opened in 2022, Tesla struggled to fill positions and faced high absenteeism rates, reportedly over 15%, well above German manufacturing norms. Part of that stemmed from Tesla's work culture, which is more demanding than traditional German industrial jobs. But part of it reflected a deeper reality. Young Germans who could work for Tesla often prefer to work for tech companies in Berlin, Munich, or abroad, where the culture is more dynamic and the pay is competitive. That creates a double problem. Germany's traditional engineering companies can't attract enough young talent, but they're also not structured to use that talent effectively. A 25-year-old software engineer doesn't want to work on diesel engine control systems, a declining technology, for a company with rigid hierarchies and slow decision-making. They want to work on AI, EVs, or renewable energy, in companies that move fast. The mismatch is stark. Germany produces approximately 120,000 engineering graduates annually, but roughly 30% leave the country within 5 years, drawn to higher salaries and better opportunities in the United States, Switzerland, or elsewhere. Germany's relatively high tax burden, the marginal rate for a mid-career engineer can exceed 42%, makes the income differential particularly painful. An engineer earning €80,000 in Munich takes home roughly €48,000 after taxes. That same engineer could earn $140,000 in Silicon Valley with a lower effective tax rate, in a city where tech culture dominates. So Germany faces a perfect storm. 1. Mass retirements of experienced engineers. 2. Insufficient young talent entering the field. 3. net emigration of the young talent that does exist, and 4. A failure to attract foreign talent at scale. Attempts to fix this through immigration run into Germany's notoriously complex visa and recognition systems. A Turkish engineer with a degree from Istanbul Technical University faces months of bureaucracy getting their credentials recognized. A Chinese engineer faces similar barriers. Compared to the United States, Canada, or Australia, which have relatively streamlined skilled immigration systems, Germany makes it remarkably difficult for foreign engineers to start working quickly. The long-term implications are devastating. Institutional knowledge in German manufacturing, the accumulated wisdom of how to run complex industrial processes, is being lost as experienced workers retire. Younger workers lack the decades of experience that made German engineering so formidable. And without young talent entering the field, the engineering workforce is literally dying of old age. Meanwhile, China is graduating engineering students at a rate that dwarfs Germany's output. In 2023, China produced approximately 5.4 million STEM graduates. India produced 2.8 million. The United States produced around 500,000. Germany produced 120,000. The sheer volume of engineering talent in Asia means that even if German engineers are individually more skilled, a declining advantage, they're simply outnumbered 40-1. This demographic reality intersects with every other crisis. You can't transition to EVs without software engineers. You can't build new factories without construction engineers. You can't maintain competitiveness without young talent driving innovation. And Germany, having ignored fertility decline for 30 years, now faces a generation-scale shortage of exactly the workers it needs most. Which brings us to the most visible failure, the absolute collapse of German automakers against Chinese competition. In April 2025, something unprecedented happened in Europe's auto market. BYD, a Chinese electric vehicle maker that barely existed in Europe 3 years ago, outsold Tesla for the first time. BYD delivered approximately 15,300 electric vehicles across Europe that month. Tesla delivered fewer. This wasn't a fluke. It was the visible manifestation of a tectonic shift that German automakers still don't know how to counter. Let's understand what BYD represents. The company was founded in 1995 as a battery manufacturer. It entered the auto business in 2003 by acquiring a failing state-owned automaker. For years, BYD was dismissed as a low-quality copycat making cars for the domestic Chinese market. Western auto executives joked about BYD's awkward designs and cheap interiors. Then something changed. BYD went all in on electric vehicles, stopping production of internal combustion engines entirely in 2022. The company leveraged its battery expertise. BYD builds its own lithium iron phosphate battery cells, giving it vertical integration that even Tesla lacks, to produce EVs at costs German automakers couldn't match. The numbers are staggering. In 2024, BYD delivered 1.76 million battery electric vehicles globally, nearly matching Tesla's 1.79 million. But BYD also sold 2.49 million plug-in hybrids, bringing total new energy vehicle sales to 4.27 million units, more than double Tesla's pure EV volume. BYD became the world's largest EV maker by volume, overtaking Tesla. Meanwhile, Volkswagen, Europe's largest automaker, delivered just 383,000 battery electric vehicles in 2024. That's down from previous years and represents less than 8% of Volkswagen's total sales. The ID.3 and ID.4, Volkswagen's volume electric models, are struggling. The ID.3 specifically has seen production cuts, shift cancellations, and price reductions of €3,000 per vehicle just to stimulate demand. So what happened? How did a Chinese company that was a joke 15 years ago become the global EV leader while Volkswagen, with 87 years of automotive heritage, flounders? 3 factors: cost, speed, and vertical integration. Start with cost. A BYD Seal, roughly comparable to a Tesla Model 3 or Volkswagen ID.4, sells for approximately $19,300 in China. That same vehicle sells for $42,800 in Germany, but even at the higher European price, it undercuts comparable German EVs while offering better range and features. BYD achieves this through radical vertical integration. The company produces its own batteries, electric motors, semiconductors, and even ships to transport vehicles. A teardown by investment bank UBS found that BYD makes 75% of components in-house, compared to 46% for Tesla's made-in-China Model 3. This vertical integration delivers gross profit margins of 16% on the Seal versus 14% for the Model 3. Volkswagen, by contrast, depends on an extensive supplier network. Bosch for electronics, LG or CL for batteries, ZF for transmissions. This traditional automotive supply chain works fine for combustion vehicles but becomes a disadvantage for EVs, where batteries are 40% of vehicle cost. Volkswagen has no battery manufacturing capability of its own. It depends entirely on external suppliers and thus can't control costs the way BYD can. Then there's speed. BYD operates in an industrial ecosystem designed for rapid iteration. When BYD decides to launch a new model, it moves from concept to production in 18 to 24 months. Volkswagen's development cycles are 4 to 5 years. That difference is catastrophic in a rapidly evolving EV market where battery technology, charging standards, and consumer preferences shift constantly. This speed difference shows up everywhere. When Tesla or BYD identifies a cost reduction opportunity, a new battery cell format, a more efficient motor design, a manufacturing process improvement, they implement it in months. German automakers run it through multi-year validation processes. The justification is quality and safety. German engineering culture demands exhaustive testing. Every component must be validated under every conceivable condition. That process produced incredibly reliable combustion vehicles. But for EVs, where the technology is simpler and competition moves faster, exhaustive validation becomes a liability. By the time Volkswagen finishes testing a new battery cell, BYD has already iterated through 2 more generations. And finally, China's EV dominance is backed by industrial policy. The Chinese government provided massive subsidies for EV purchases, built extensive charging infrastructure, mandated that major cities transition to electric buses and taxis, and restricted license plates for combustion vehicles in major metros. This created a domestic market of 10 million EVs sold annually, more than the rest of the world combined. That huge domestic market gave Chinese EV makers scale advantages German automakers can't match. BYD's Shenzhen factory produces 600,000 vehicles annually. That volume drives down per unit costs through economies of scale. It amortizes R&D costs across more vehicles. It justifies billion-dollar investments in battery production that smaller manufacturers can't afford. Now Chinese automakers are exporting that scale advantage globally. BYD is building factories in Hungary, Brazil, and Thailand. It's exporting hundreds of thousands of vehicles to Europe, Southeast Asia, South America, and Australia. The company is leveraging Chinese manufacturing costs, Chinese battery technology, and Chinese speed to undercut incumbents everywhere. For German automakers, this is existential. Volkswagen's Wolfsburg plant, the world's largest automotive factory, operates at roughly 61% capacity utilization. Mercedes' Sindelfingen plant, 44%. These plants were designed for producing 1 million vehicles per year. They're producing far less, because demand for German EVs is weak. Some of this stems from product deficiencies, the software problems, the less competitive pricing, the slower charging. But fundamentally, German automakers are being out-manufactured. Chinese companies can produce comparable vehicles faster and cheaper. The engineering excellence that made Mercedes and BMW premium brands matters less when a BYD offers 90% of the capability at 60% of the price. German automakers see this happening and don't know how to respond. They can't match BYD on cost without vertical integration they don't have. They can't match on speed without abandoning validation processes that define their engineering culture. And they can't match on scale because China's domestic market is larger than Europe's and growing faster. This is China Shock 2.0. The first China Shock, in the 2000s, hit low-cost manufacturing, textiles, consumer electronics, furniture. Western countries could retreat up the value chain, focusing on high-tech, premium products. But this China Shock hits the premium segment directly. Chinese EVs aren't just cheap alternatives. They're genuinely competitive premium products that happen to also be cheaper. And while German automakers struggle with Chinese competition, they also struggle with something uniquely German, their own bureaucracy. In January 2019, Tesla broke ground on Gigafactory Shanghai. In December 2019, less than 12 months later, the first production vehicles rolled off the assembly line. Tesla built one of the world's largest automotive factories, capable of producing 500,000 vehicles annually in 11 months. In November 2019, Elon Musk announced Tesla would build Gigafactory Berlin. In March 2022, roughly 28 months later, the factory finally opened. Both factories use similar construction techniques: prefabricated steel structures, modular designs, rapid assembly. Both produce the Model Y. But one took 11 months. The other took 28 months. What happened in those extra 17 months? German bureaucracy. The permitting process alone consumed over a year. Tesla needed approval from federal authorities, state authorities, and local authorities. Environmental groups filed objections about water usage, tree removal, and potential impacts on local wildlife, particularly the sand lizard, a protected species. Each objection triggered additional reviews. The initial construction permit was challenged in court multiple times. Even after receiving conditional permits, Tesla faced restrictions. The company couldn't begin certain construction phases until specific environmental mitigation measures were completed. Tesla couldn't fully ramp production until final approvals came through, which arrived weeks before the official opening. This wasn't unusual. This is how Germany works. The regulatory system is designed to be comprehensive, to consider every stakeholder, to prevent any possible negative externality. That produces safe, sustainable, well-planned development. But it also makes Germany one of the slowest places in the developed world to build anything. Compare that to China. When Tesla negotiated Gigafactory Shanghai, the Shanghai municipal government expedited every approval. The land was cleared before Tesla signed the final agreement. Permits were issued within weeks. Construction started immediately. When Tesla needed grid connections, they appeared. When Tesla needed workforce training, local technical schools adapted curricula. The government treated Tesla's factory as a strategic priority and mobilized resources accordingly. The result: Shanghai took 11 months. Berlin took 28 months. That's a 155% time premium for identical construction using identical techniques. Now consider what that means for German companies trying to build in Germany. If Tesla, with its global brand, enormous resources, and Elon Musk's public pressure, needed 28 months to build in Germany, how long does it take a smaller firm? Or a traditional German manufacturer navigating the same system? The answer: often 4 to 5 years from concept to completion. German automotive plants typically take 3 to 4 years to build. Chemical plants take longer, 5 to 7 years, including permitting, environmental reviews, and construction. Every month of delay adds costs: interest on construction financing, inflation on materials, competitive disadvantage as markets evolve. This regulatory burden has real economic consequences. According to Germany's IFO Institute, bureaucratic costs consume approximately 3.3% of German GDP annually, roughly 120 billion euros. That includes direct costs, fees, compliance staff, and indirect costs, delays, foregone opportunities, reduced investment. For industrial investment, the impact is particularly severe. When BASF considers where to build a new chemical plant, they compare Germany to China, Singapore, or the US Gulf Coast. In Germany, the project takes 6 years from concept to production. In China, it takes 3 years. In Singapore, 3.5 years. That timeline differential often determines the decision. BASF builds in China. The same pattern repeats across industries. ThyssenKrupp's recent steel investments went to sites outside Germany. Battery factories are being built in Poland, Hungary, and elsewhere in Eastern Europe. Cheaper labor, less bureaucracy, faster permitting. Even German companies are choosing not to build in Germany. Part of this reflects Germany's federal structure. Unlike France or the UK, where the national government has decisive authority, Germany distributes power across federal, state, and local levels. Each level has veto authority over certain permits. Environmental groups have extensive legal standing to challenge projects. The result: any major industrial project faces a gauntlet of approvals, objections, reviews, and potential legal challenges. The justification is democratic legitimacy and environmental protection. And there's truth to that. Germany's environmental regulations prevented the air and water pollution that plague parts of China. Germany's worker protections ensure safe workplaces. These aren't bad things. But they're also not free. Speed matters in industrial competition. Being able to build a factory in 11 months instead of 28 months means you can respond to market opportunities faster. Being able to expand capacity quickly means you capture growth. Being able to site new facilities without years of regulatory negotiation means you're competitive. Germany optimized for deliberation, consensus, and comprehensive regulation. China optimized for speed, decisiveness, and execution. For stable, mature industries, Germany's approach worked fine. For rapidly evolving industries like EVs or semiconductors or renewable energy, where technology cycles measured in months determine winners, Germany's approach is simply too slow. German companies see this. They know their home regulatory environment is slower than competitors abroad. But they can't change it. Germany's political system is diffused. Environmental groups are powerful. Public opinion favors extensive review. No single actor can force faster approvals. So German industry faces a bizarre situation. The country that rebuilt itself from wartime devastation in 15 years now can't build a car factory in less than 3 years. The engineering culture that produced the Wirtschaftswunder, the economic miracle, is now trapped in bureaucratic quicksand. And all 5 of these crises compound into something worse than their sum. These 5 failures don't exist in isolation. They form a doom loop where each crisis amplifies the others. Start with demographics. An aging engineering workforce means Germany lacks the young software talent needed to compete on EVs. That talent shortage makes the Spaltmaß Trap worse. There's no one to shift engineering culture from mechanical perfection to software velocity. Meanwhile, young Germans who could be engineers are leaving for opportunities abroad, partly because German industry offers lower salaries due to its energy cost disadvantage. That energy disadvantage, in turn, makes German manufacturing less competitive, which reduces industrial investment, which means fewer engineering jobs, which accelerates the brain drain. Companies like BASF are moving production to China not just because energy is cheaper but because Chinese engineers cost less and Chinese regulatory approval is faster. The bureaucratic paralysis compounds everything. Germany can't build factories fast enough to respond to Chinese competition. By the time Gigafactory Berlin opened, Tesla had already been producing Model YS in Shanghai for 2 years. That head start in production learning allowed Shanghai to refine manufacturing processes, reduce costs, and optimize quality while Berlin was still getting permits. The regulatory delay created a competitive disadvantage. And China Shock 2.0 feeds back into every other problem. As BYD and other Chinese automakers capture market share, German automakers lose revenue, which forces cost cuts, which reduces R&D spending, which makes German vehicles less competitive, which accelerates market share loss. Volkswagen's factory capacity utilization falls, Wolfsburg at 61%, Sindelfingen at 44%, which increases per unit costs because fixed costs are spread across fewer vehicles, which makes German cars even less price competitive. The doom loop extends to the macro level. Lower industrial output means lower GDP growth. Germany's economy grew just 0.2% in 2023 and contracted slightly in 2024. Slower growth means less tax revenue, which constrains public investment in infrastructure, research, and education, exactly the areas Germany needs to invest in to regain competitiveness. The fiscal constraints also limit Germany's ability to subsidize its energy transition, making the energy disadvantage persist longer. Meanwhile, Germany's political system, designed for stability and consensus, struggles to respond quickly. Regulatory reform requires federal legislation, which requires coalition negotiation, which takes years. Energy policy reform is politically radioactive. Reopening the nuclear debate is electoral poison. Immigration reform faces populist backlash. So Germany knows what its problems are but can't fix them fast enough. The result? A structural decline that's accelerating. Each year, German industry loses more ground to Chinese competitors. Each year, more production capacity moves abroad. Each year, more young engineers leave. Each year, the doom loop tightens. This isn't cyclical. This isn't a recession Germany will grow out of. This is a permanent shift in competitive advantage. The industrial model that made Germany Europe's economic engine, cheap energy, precision manufacturing, deep technical expertise, stable regulation, has been demolished by a combination of geopolitical shocks, technological transitions, and demographic realities that converge at the worst possible moment. The German engineer, once the emblem of industrial competence, now symbolizes an era that's ending. Not because Germans can't engineer, they still can brilliantly, but because the world no longer needs the kind of engineering Germany offers. Perfect panel gaps don't matter when the car's software doesn't work. Decades of diesel expertise are worthless when the market wants EVs. Comprehensive regulatory review is a liability when competitors build factories 3 times faster. Germany optimized for the 20th century. The 21st century has different winners. Made in Germany used to be a promise. It meant something you bought would work perfectly for decades. That promise was built on an industrial model that no longer exists. Cheap Russian energy, patient capital, long engineering development cycles, mechanical precision as the primary differentiator, and a workforce that stayed in place for generations. Every piece of that model is now broken. The energy is expensive and unstable. Capital demands faster returns. Engineering cycles are measured in months, not years. Software matters more than mechanical precision. And the workforce is retiring without replacement. Germany still has excellent engineers. It still has advanced manufacturing capability. It still has quality standards. But none of that is enough anymore. Because the competition isn't other European countries playing by the same rules. It's Chinese companies that build factories in 11 months, produce EVs at half the cost, iterate software monthly, and operate in an industrial ecosystem designed for speed. The German response has been too slow, too incremental, too constrained by political realities and regulatory structures that can't be reformed fast enough. Volkswagen knows it needs better software, but hiring 3,000 software engineers into an organization of 120,000 mechanical engineers doesn't change the culture. Germany knows it needs faster permitting, but reforming a federal regulatory system requires political consensus that doesn't exist. So the decline continues. Not because Germans don't see the problem, they do clearly, but because fixing it requires changes so fundamental to Germany's economic model, regulatory structure, and engineering culture that they're essentially impossible at the speed needed. Made in Germany isn't dying because Germany stopped making quality products. It's dying because the world stopped valuing what Germany makes. And the transformation required to make what the world values, cheap EVs, fast software updates, rapid iteration, contradicts everything that made German engineering legendary. If this analysis was valuable, consider liking and subscribing for more investigations that go beneath the surface. Thanks for watching. I'll see you in the next one.